So, hi everyone. I'm here to talk about a Shiny app we developed to help to improve the Brazilian public school geolocation. And I'm talking on behalf of Nick.br, my company. Not like the company I work for, sorry. And I'm going to start with why did we build such an app? And to give you a little bit of context, like in Brazil, we have this governance model for the internet, which is basically, yeah, we'll get to the schools. I know it's weird, but we have this multi-sector model with the internet steering committee, which is like there's people from academia, people for the public sector, from like third sector, and the main mission of this steering committee is to improve the internet access and quality in Brazil. And we have this associated company, which is not Nick.br, that is equivalent to the RIPES NCC here in Europe, which is like regional internet registry. And basically what we do is like we put all the CGI decisions into practice. For example, we build internet exchange points in Brazil. We conduct different ICT service. And we developed this internet quality measurement tool. And this is what I want to talk a little bit more. The team responsible for this measurement tool is the broadband measurement area, and this is where I fit in within Nick. And we aim to contribute to the universalization of internet access. We try to understand patterns of connectivity in Brazil. We try to identify digital inequalities and enable assertive decision-making by stakeholders. And to do so, we developed this measurement tool called CIMAT, and people in Brazil, they can install this measurement tool or they can use it in the web browsers. And once they do, we collect this data and we get to monitor and analyze the internet quality in Brazil. So we produce a lot of reports and we produce a lot of Shiny apps to make sure the public get to access this data. And we have a special version of the software that we install in the Brazilian public schools. So we get to monitor like in real time, like almost real time, the internet quality we provide to our students. And this is what we call like the public school project. And within the scope of this project, back in 2020, we were like, oh, it would be cool to have this website where we could show all the schools, create this map with several ICT indicators. And we actually did build this website. It's a whole new other Shiny app, not the one I'm talking about today. But since we're talking about the map, we were like, oh, let's plot all schools within the map. But when we tried to do that, we found out like about 30% of Brazilian schools had no geolocation data. We had no idea where they were. Like, we knew, oh, it's in this city. But where in the city, we had no idea. And some schools we did have, yes. Some schools we did have the geolocation data were placed in the middle of the ocean. So clearly a typo at the process. So, and it's not only that we wanted to see the schools in the map to look pretty, but this kind of information is important for centralized high-level education policies. For example, if you want to calculate the distance for a school to the nearest fiber connection, or if you want to estimate costs of connecting a school, for example, if you could ask yourself, should I connect those 3 schools that are close together, or should I connect that one other school that is further away? This type of question can only make sense once you have the school location. Otherwise, it won't make sense. So overall, this type of data can improve educational planning. So taking all that into account, we have started this crusade to find all schools, which is kind of a challenge. And right now, I'd like to do this quick disclosure. Brazil is huge, and like UK fits about 35 times into Brazil. And it's not only that we are huge, we are also complex. We are divided into 5 major regions, 27 states, and more than 5,000 cities, which means different administrative levels. For example, some schools belong to the state, some schools belong to the city. So how can we manage all that? And all this complexity gives us around 106,000 public schools. And so, yes, this is the size of the challenge, more or less. And creating the web app was not our first solution. We have tried to talk with affiliated organizations, so we are always in contact with the telecommunication agency. Maybe they know because they monitor the network fiber. Maybe they know. The internet providers, because most of those schools already had internet. So someone was there to install it in most cases. Someone must know, only that the main government didn't. And we have tried geolocation API, so we have tried all of them, I guess. OpenStreetMap, TomTom, Bing, and Google, and they can be wrong. Often they would place the school in a different state based on the address. So, and it's we have to accept it with caution, this data. And we have tried visiting. This is something personal for me. I always travel with a list of those unlocated schools whenever I'm in vacations or business. But it's not something it's not something you can do in a national scale. Not that I haven't asked my boss about it. He never said yes for me to go on this trip. And this has taken us so far, it has helped. Out of that original data source, which was from the Ministry of Education, the one with the schools outside in the ocean, we had about that much schools. Affiliated organizations helped us with about 5,000 schools. And APIs helped us a lot, around 30,000 schools. We do some checks out, we don't blindly accept those data. But we were still missing around 19,000 schools. And at this point, we realized we could not do this by ourselves. We would need to get help, and we would need to get help from those on the ground. Maybe because it's not that the school doesn't exist or they are not working. They are working, so the principal must know where the school is, so he can attend there. And we try to, at this point, we need some way that the person in the ground can help us. So I link with a website he can access and locate the school for us would be perfect. Maybe a Shiny app can help us with that. And this is basically how the Shiny app works. You enter, this is how you see once you enter, and then you can enter the school ID. Then it shows our best geolocation for that school so far. It maybe comes from an API, so it's not that accurate. And see, it is in the middle of the river. And you can switch to satellite imagery. And you can say, okay, I know it has to be by the river around here. You can zoom in, you can check this construction. This is the school. I know that because I work there. And then you can zoom out. You can change back to the street layer. And that's basically it. That's how the app works. And you can press send geo. And then it should pop up this notice saying, are you sure you want to send the geo? And you can press yes. And that's it. This is the app. It's not very complex at all. But the thing is, when we were it is quite a simple app. It doesn't take much. And when we first thought about building it, we thought the main challenge would be how could we get the geolocation from the leaflet click? Because the person has to click on the screen. How do we collect this data? But it turned out to be quite simple. There is this _click property of leaflet maps. It automatically gives you the latitude and longitude. So that was pretty easy. And once the person pressed send, we post the coordinates through an API into a Postgres database, and we store basically timestamp of the contribution, the school ID, latitude, longitude, and some user info. And basically that's it. That's how the app works. And since we're talking about Shiny, well, this is the package we use, which are not that many. For Shiny stuff, Shiny.js, Shiny widget, for SF, leaflet, and leaflet extra for mapping stuff, dplyr for data manipulation, of course, and curl, JSONLite, and HTTR for API communication. So not that many packages, quite simple. And here's the fun part. Like I really like it because basically we got the app has been running for 1.5 years now, and we got that many contributions for schools, which is more contributions than with schools we have. But those contributions were for 22,000 different schools, so quite nice. And out of those 22,000 schools, 675 were schools we had no previous information. Like we had like no idea where they were. So you can say it's not much, 0.5% is not much, but we didn't invest much. It was like effortless data we received. And that's those 675. I have trouble with numbers in English, sorry. That's those schools over there. But we are having some kind of struggles. And they are mostly related to the fact that we got that many contributions. We have an average of 3 contributions per school. And how should we choose among the contributions which one is the best, like which one is the real one? So we developed this algorithm to try to choose between, and it works more or less like this. We first choose the last contribution within 10 minutes because the way the app works today, the person makes its contribution, the person is happy, she's contributing, and she wants to see the result. She wants to see her contribution on the screen, so she refreshes the page. But then, when she refreshes it, the pin that shows is the previous one because we only store it, we don't real-time update it. So the person gets confused, and we assume she will assume that something went wrong, so the data was not collected, so we should do it over and over again. So this is the first treatment we do. Otherwise, after that, we ask, has the school been geolocated before? If it's a no, how many contributions are left after the 10 minutes treatment? If it's 1, we'll accept it. If this is the best information we have for that school. If it's more than 1, we choose the contribution with the smallest distance to all others. So basically we do this distance matrix and choose the smallest sum of distance. If the school has been geolocated before, we ask ourselves, what was the original source? Because EASE, which is one of the affiliated organizations, we really trust their data because they're technicians that are installing the internet in the school, so they know their way around like collecting geolocation, so we do trust them. So we keep the original source. And if it is from MAC, which was that original database, or through the APIs, we will treat it as there was no contribution before, and then we do the matrix thing. We were happy about it. Like it was working until about a month ago, which was after I sent the abstract, and and someone emailed us, and the person said, "Oh, the geolocation showed in another website, not this one, is wrong. Here's the correct geolocation." When I looked over the correct geolocation, it was the same as we had before, which was from the Ministry of Education source. So we were like, someone logged into the web, like to the web app, changed the school location to a wrong one, and right now, we are thinking on how to deal with that. So ever since we received this bad feedback, we are only accepting those 675 schools as like contributions, real contributions. And we are thinking about how to deal with the other contributions. So maybe we should change the way the app works, the Shiny app works. So once you press send, maybe you should do a real-time update. and then the person will be happy, wants to see her contribution on the screen. We haven't done that like at the beginning because there was some technical difficulty. It was technically difficult. So at some point. So, but maybe we should try harder at this point. Maybe we should inform the user about how the Shiny app works. So once the person press button, maybe we should like notify them that your contribution will be created and maybe accepted within a few weeks, so the person won't be anxious about it. Maybe we should prevent geolocation contributions for schools we trust the original data source. So, for example, when the person enters the school ID, we can say, oh, we already have good intel for this school, no contributions needed, thank you. Not the best, like, I wouldn't like to read this message. And maybe we should change the source we trust, because after we received that bad feedback, we asked someone to go over, this person was working in this project, she was trained to identify schools through satellite imagery, and she went through 1,000 images from Mac, and out of the 1,000 images, she was like, only 3 doesn't look like school at all. So maybe we should trust this data source and treat this just the same way we treat EASI. But still, any suggestion would be highly appreciated. If you have been through something like this before, you have any idea, any thoughts at all, I'll be glad to discuss it. Come talk to me right now or afterwards. And this is it. That's what I had to talk about. Thank you very much.